What I'd like to talk to you today about is how to use native ASAP geometry to create rather complex forms of geometry that can be readily parameterized and therefore changed during either an iteration or optimization in ASAP. And here's a simple example of what I'm talking about. Right here, what I've created is geometry that's basically a four-sided prism. It has three faces. It has the base, it has the sides, and I also have the tip region, because obviously when prisms are manufactured, they don't come to perfect points like we simulate in a CAD program. Due to manufacturing effects, typically they're somewhat flattened at the top face. So again, this is a simple model, but what I've done in ASAP is to create this using surface geometry. Now, obviously, I could have gone into a CAD program and I could easily create that within a CAD program. But if I had done it in a CAD program, every time I wanted to change it, I'd have to go back to my CAD program, modify the file, save it, export it, re-import it, etc. But now what I've done in ASAP is by creating this simple surface type geometry that I've built using these parameters right here, I can easily change my geometry simply by coming up and changing my parametric values. So initially I started with a prism that was 5 by 5 in terms of height, but I could also make it a bit longer, or I could make it a little bit narrower readily and simply recreate the geometry. And again, I could do those changes to my geometry while I'm either optimizing or simply doing iterative processes on my system. And of course, in this particular case, what we might want to do is then trace some rays through that geometry. And obviously right now, since I've got the long, narrow prism, we see that due to TIR, many of the rays end up exiting out the side due to frustrated TIR. And some of those rays TIR and eventually exit back out the input face. Now, the main advantage we have to using ASAP surface types as opposed to CAD geometry is when I'm using surface types in particular within ASAP, surfaces can almost always be modified to be arrayed. So what I can do with the array capability of ASAP is to simply take this same geometry and make a large number of them. So here I've taken the exact same prism structure. In this particular case, I have a 5 by 5 geometry, just as we started with before. But what I've also now done is set up an array of cells in the X and the Y direction. So now my geometry looks a little bit more like this. And what I'm going to do is I've also defined a couple detector surfaces. So let me just quickly turn those into wireframes so we can look at it. And now you see I have the same basic prism geometry, but I have an array of those structures. And now I can trace rays through this whole system. And let me do that right now. And I'm only looking at a few of the rays that are coming through the system. But we can see this is the intensity that I defined going into the system, which was basically a Lambertian distribution out to plus and minus 60 degrees. But because of the TIR and the other effects as the light was passing through the system, we end up with an intensity distribution that has been narrowed. We see the area out here in the wings because of the fact that some of those rays that exit one prism end up interacting with another prism before they actually reach my target face. And some of that we can see by zooming in on our ray trace here. And as you can see, this is a rather interesting ray right here. We come up and will totally internally reflect off one of the sides, then off the base, before we exit out another side, and then end up interacting with the adjacent prism. This leads to another capability of, and probably one of the more important capabilities of array surfaces within ASAP. Another option in the array command is the search modifier. What the search modifier allows you to do is to tell ASAP that when a ray interacts with one particular unit cell of this geometry, to determine which other objects the ray might have interacted with, it only needs to search a closely spaced adjacent region. In this particular case, search 2 says go out a circular zone 2 sets of prisms wide. In reality, in this case, I probably could have limited my search only to the adjacent prisms. What this does is significantly limits the possible ray surface intersections that ASAP has to test for, significantly speeding up the ray trace calculation. Another advantage to using the array mechanism within ASAP is, although I have a large number of peens, I still have a very small number of pieces of geometry. So I can create a very, very large array structure without significantly impacting the number of objects within my entire system.